Okay guys, this is Math 1513, College Algebra, Northern Oklahoma College, Chapter 8. We're doing sequences and series. Alright, now the difference between sequence and series, a sequence is just a list of numbers. Okay, in this case we're adding 2 every time. 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, and so on. We call that a sequence. It's just a list of numbers that are following some sort of pattern. A series is if we add all those numbers up together. So that sum, if I add the 1 plus 3 plus 5 plus 7 plus 9, that sum is called a series. Now let's say I have the sequence that it starts with 2 and I add 3 every time. So then I get 5, 8, 11, and 14 because I'm adding 3 every time. Well, that's called an arithmetic sequence because we're adding the same number every time. We're adding 3. Now that 3 that we're adding is called the common difference. And we find that common difference by taking any number, for example 8, any number in the sequence, and subtract the number that came before it. So 8 minus 5 equals 3. Or I could do 14 minus 11 equals 3, or I could do 5 minus 2 equals 3. Now, something else we're going to need to know is how these terms in the sequence are labeled. They label them with the letter A, so each term is going to be called A, and then you just list which number in the sequence it is. So A sub 1 would be the first term in the sequence, A sub 2 would be the second term, and so on. A sub 3 would be 8, A sub 4 would be 11, A sub 5 would be 14. So the little sub number, we call it sub because it's written down low. It's kind of like an exponent, but it's down low. The sub number tells you which term it is. So your first term is 2, your second term is 5, your third term is 8, and so on. Well, what if I want to find a certain term in the sequence without doing it by hand? Like I was doing up here, 2 plus 3 is 5. And if I don't want to do it by hand the long way, what if I want to find a certain term? For example, let's say I want to find the 5th term in this sequence. Now, we've already done it by hand and we know it's 14, but they have a handy little formula here to use for, like extremely high numbers. Maybe I want to find the 100th term or the 1000th term. You don't want to do that by hand, so we want to use the formula. So let's say I'm looking for the 5th term. So A sub 5, because I'm looking for the 5th term, would be A sub 1. That's the first term. What was our first term? 2, plus the number of the term we're looking for. We're looking for the 5th term. Remember, n was 5. Minus 1 times the common difference. And we calculated the common difference was 3. So that's times 3. Now we just do the math. So 2 plus 5 minus 1 times 3. 5 minus 1 is 4. Times 3 is 12. Plus 2 is 14. And we found that our 5th term is 14. Now, like I said, if you're just calculating the 2nd or 3rd or 4th term, you might want to just do it by hand. But if they ask you for like the 24th term in your homework or whatever, you would probably use this formula. It would be quicker. Alright, what if we wanted to find a series? Remember, a series is if you add the terms up. So what if we want to add the first 5 terms of our sequence, the 2 plus the 5 plus the 8 plus the 11 plus the 14? Well, we can always do it by hand and get 40. And that's called a partial sum. I didn't add up the whole sequence out to infinity. I didn't add a million numbers together. I just added a partial sum. I added the first 5. Alright, so to find a partial sum, well, you can do it by hand if it's just a few of them, but if you have a whole bunch to add together, you want to use one of these two formulas. And these will both work. I'm going to work them both out. This first formula is easy to use if you know the first term and the last term of the sequence that you're adding. So we know that, so I'm just going to go ahead and use this one. S sub 5, that means I'm going to sum the first 5 terms. I'm going to add the first 5 terms of this sequence together. Equals n over 2. Well, n is 5 because I'm adding 5 terms. Over the first term, or times the first term, which was 2, plus a sub n. Well, that's a sub 5. That's my 5th term, which is 14. And then I do the math. So s sub 5 equals 2.5. 5 over 2 is 2.5 times 16. And 2.5 times 16 gives us our 40, which we already knew it was going to be 40 because we did it by hand. But here's a formula that works if you know the first and last term. Now, if you don't know the last term, you might want to use this longer formula because all you need for the longer formula is the number of the terms that you're adding and the first term and the common difference. So if that's all the information you have, use this longer formula. So I'm summing 5 numbers, which is 5 over 2 because n is 5, and then 2 times my first term, which is 2, plus n, which is 5 because I'm adding 5 terms, minus 1 times my common difference of 3, which I calculated earlier. So s sub 5 still equals 2.5 times 16, and you still get 40. Alright, so use this shorter formula if you know the first and last terms, and use the longer formula if all you know is the first term and the common difference. Okay, what about geometric sequences and series? Geometric just means that you're multiplying by the same number every time. So for example, this series right here, 2, 6, 18, 54, 162, I'm multiplying by 3 every time. I started with 2 and went times 3 to get 6, times 3 to get 18, times 3 to get 54, times 3 to get 162. All right, when we multiply by 3 like that, that is called a common ratio. Now our common ratio, we designate that using lowercase r for ratio. Common ratio is 3. Now that was obvious, we were multiplying by 3, but if you need to calculate it, you just take any number in the series, for example 18, any number in the sequence, 18, and divide it by the number that came before. So I could do 18 divided by 6 equals 3, or I could do 54 divided by 18 gives me 3. I can pick any number in the sequence and divide it by the number that came before to calculate r. Now what if I want to find a certain term in this geometric sequence? Well, I would use this handy little formula right here. It says whatever term you're looking for, you need the first term times the common ratio raised to the n minus 1 exponent. All right, so let's say I want to look for the fourth term. Now we've already found the fourth term by hand up here. It's 54. But for larger numbers, like if I wanted to find the 100th term or the 1000th term, I'd want to use this formula here. So I'm looking for the fourth term. So I write a sub 4 for my fourth term equals my first term, 2, times my common ratio, we calculated that to be 3, raised to the n minus 1. Well, n is the number of term you're looking for, in this case 4. So 4 minus 1. Now we just do the math. 2 times 3 raised to the third power is 2 times 27, which gives us our 54. Now we already knew it was going to be 54, but I'm just showing you how it works in case you want to find a higher term in the sequence. All right, now what if I want to find a partial sum? Now you guys remember a series is just the sequence when we add all the terms up. All right? Now a partial sum means I'm just adding part of the sequence. I'm not adding all the numbers out to infinity. I'm just adding the first 3 terms or the first 4 terms or the first 5 terms. In this case, my partial sum was adding the first 5 terms, and that's my series there. And I got a sum of 242 by hand. Now you can always do it by hand if it's a little one, but what if you want to add, 100 terms or 1,000 terms? Well, then you have to resort to this nasty looking little formula down here. So to find a partial sum, you want to sum however many numbers you want to sum, however many terms you want to sum. You need the first term, 1 minus the common ratio, raised to the number of terms you're adding, over 1 minus the common ratio. All right, my substitution looks like this. I'm summing the first 5 terms equals the first term, 2, times 1 minus my common ratio, 3, raised to the 5th power because I'm adding 5 terms, that's my n, over 1 minus my common ratio, 3. And then I just do the math. And we come up with 242 for the sum of our 5 terms, which we had already worked out by hand up here. We had added our first 5 terms and got 242. And if you're just finding the sum of 2 or 3 or 4 or 5 terms, it might be quicker to do it by hand. But if you're looking for the sum of 100 terms or 1,000 terms, you probably want to use this formula here. It'd be a lot quicker. And finally, to sum an infinite geometric series. That means if I do want to add every single term in the sequence all the way out to infinity, I'd use this formula here. But there's a exception. This only works for r's less than 1. So your common ratio, the number you're multiplying by every time, needs to be less than 1. In other words, a fraction. So I'm going to have to come up with a different series here, a different sequence. Okay, so here's a sequence, 2, 1, 1/2, 1/4, 1/8, 1/16, where I'm multiplying by 1/2 every time. I calculated r over here, so I took the term 1/2 and I divided it by the term that came before it, 1, to get 1/2 for my r. Now since r is less than 1, since it's a fraction, I can use this formula to add up all the terms in this series. So if I add all the terms in this series, what will I get? Let's just plug the numbers into this formula and find out. All right, so my first term, a sub 1, is 2 over 1 minus my r. My common ratio is 1/2, which I calculated over here. So 2 over 1 minus 1/2 is 2 divided by 1/2, which is 4. What does that mean? It means if you add all the terms up in this series all the way out to infinity, it'll get closer and closer and closer and closer to the number 4. It'll approach 4 and become infinitesimally close to 4 without actually being 4. But it's approaching 4 is what we say. Now we can do this. Let's add a few of these by hand and just watch. 2 plus the 1 gives me 3. Plus 1/2 gives me 3 1/2. Plus 1/4 gives me 3 3/4. See how it's getting closer and closer to 4? But the numbers that we're adding on here are getting smaller and smaller and smaller and smaller and smaller all the way out to infinity. So that by the time we get to, infinity, let's say we could go there, by the time we get out there to infinity, the number that we're adding is so small that it doesn't change anything. So our sum is going to get closer and closer and closer to 4. It's going to approach 4 and almost get there, but not quite. Alright, the last thing I'm going to show you is how to expand a binomial. Expand just means multiply it all out. So here's a binomial. Here's first term 2x and second term 3y. And we want to raise that to the 4th power. What that means is we need 4 of these groups all multiplied together. Now we could do it by hand, and do the distributive property or FOIL, and we just multiply that all out over and over and over again, and it would use about a page of paper. But I don't want to do it that way. I just want to use this trick that somebody figured out. Alright, here's how the trick works. Now notice I've written a whole bunch of parentheses, and I'll show you how this works. Now in this big parentheses, that's going to be our binomial coefficient. And it's going to start with our exponent of 4 on top and 0 on bottom. The next one will be 4, 1, then 4, 2, and then you keep going until they match up. There's 4, 3, and there's 4, 4. So you keep adding binomial coefficients until they match up at 4, 4, or 5, 5, or 6, 6, or whatever your exponent happens to be. Now calculating the binomial coefficient, you can do on your calculator if you have a little key that looks like something like that. It'll look like a capital C with maybe an N in front of it and maybe an R after it. And to plug this into your calculator, you would press the number 4 and then hit your NCR key and then press the number 0, and it would give you that binomial coefficient. There's also a way mentioned in the book to calculate it using factorials. So you can use either way. I recommend figuring out how to use your calculator and coming up with these binomial coefficients. The next thing we want to do is we want to put our first term, 2x, into this parentheses right here, all the way down. 2x, 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 all the way down. The second term, 3y, goes in the parentheses right next to it. All the way down. And the last thing we have to do is put exponents on these. Now, we start by putting an exponent of 4, that's our exponent that we're starting with, by putting an exponent of 4 outside the 2x group. And the next 2x group has an exponent of 3. It goes down 1. And the next 2x group has an exponent of 2, and then 1, and then 0. Now the 3y groups do the same thing, but they go backwards. My 4 would start back here. Then this 3y group has a 3, this one a 2, this one a 1, and this one a 0. That's the substitution part. Now we just have a couple lines of math to do, and we've got it. Alright, I've calculated my binomial coefficients, and I get a 1, 4, 6, and then back down to 4 and back down to 1. It kind of acts like a staircase. It goes up to a peak and then back down using the same numbers. Next, I go to my 2x, and I'm raising it to the 4th. Now I'm raising not only the x to the 4th, but I'm also raising the 2 to the 4th power. So what is 2 to the 4th? That's 16. What's x to the 4th? That's just x to the 4th. So my binomial coefficient is 1. My 2x raised to the 4th is 16x to the 4th. And my 3y raised to the 0, well, anything raised to the 0 is 1. Next comes my plus sign. So I have 1 times 16x to the 4th times 1. That's my first term. Plus, and then I do it again over here. 2x cubed means I cube both the 2 and the x. 2 cubed is 8. X cubed is x cubed, and 3y raised to the first power is still 3y. Anything raised to the first power is still 1. Make sure you put your plus sign in between these groups here. So my second term, I have 4 times 8x cubed times 3y. And I've finished off all the substitution here. 6 times 4x squared times 9y squared plus 4 times 2x times 27y cubed plus 1 times 1 times 81y to the fourth. Okay, the last thing we have to do is just multiply these terms together. So this is 1 times 16x to the fourth times 1. That's just 16x to the fourth. That's my first term. Plus, do the multiplication here. 4 times 3 is 12, times 8 is 96, and then we have an x cubed, and we have a y, and we continue. And the rest of it is 216x squared y squared plus 216xy cubed plus 81y to the fourth. And there we've done it. We've raised 2x plus 3y, that group, we've raised it to the fourth power without doing a whole page of work. Really, we only had to do 1, 2, 3 lines of work using this technique. All right, now I want to do one more and just show you what happens when there's a minus involved. So we're raising this group, 2x minus y to the third power. That means our binomial coefficient starts with 3 over 0, 3 over 1, 3 over 2, whoops, and I left off 1 here, and 3 over 3. So we're going to have that many terms. And now we put in our first term there, 2x, and the second term is going to be a negative y. All right, so 2x and negative y. Here's what it looks like with the terms and the exponents put on. So 2x squared negative y to the 1, etc., etc. All right, and I've worked out my binomial coefficients, 1, 3, 3, 1. And now I'm going to plug in 2x cubed. We'll have to cube both the x and the 2. That gives me 8x cubed. Anything to the 0 power is the number 1. All right, but let's go over to this one here. 2x squared, that's going to be 4x squared. Square both the x and the 2. Negative y to the first power is going to be negative y. And how that's going to affect things is now I have a 3 times a 4 times a negative number. So our answer is going to wind up being a negative number. 3 times 4 is 12, then my x squared, then my y. So that's how the negatives affect it. Now I'll go ahead and finish the problem. And let's look at our results. 1 times 8 times 1, that's going to be 8x cubed, and it's positive. Then we jump to negative. 3 times 4x squared times negative y gives us negative 12x squared y. And now back to positive because negative y, when we square it, that's negative y times another negative y, gives us a positive y squared. Multiply it out gives us a positive 6xy squared. And finally, negative y cubed, I'm off the screen here, negative y cubed is negative y times negative y times negative y, which ends up being negative y cubed. Multiplied out gives us minus y cubed. So notice how expanding a binomial with a negative sign, with a minus sign, makes the signs on your answer bounce back and forth from positive to negative to positive to negative. Okay?